Hello everyone, welcome to Streamr webinar. My name is Wei Lei and I'm the head of developer relations at Streamr. The goal of today's webinar is to walk you through a Streamr platform and Ethereum and how you can leverage both to build complex blockchain applications. We will split this session to two main parts. The first one is to showcase how you can deploy smart contracts over Ethereum public blockchain. To do so, we'll be using the Ethereum Rinkeby testnet, primarily because you can get free ETH coins for that. If you wanted to deploy contracts on the mainnet, you probably have to pay real money for that. In the second part, we'll focus on how to manage large volume real-time data streams and how you can make it interact with smart contracts via event triggers by leveraging Streamr. So to demonstrate both scenarios, we have created a demo called cold chain monitoring that we'll showcase pretty quickly. So the demo is built around the use case of a shipping company servicing refrigerated goods. Our goal was to give clients a way to monitor the journey of their refrigerated goods, but also active control on implementing a penalty system and also temperature threshold. In doing so, the goal was to protect the good from spoiling, get a refund or partial refund if that scenario happened, and also to incentivize good behavior from the shipping company. All these can be automated via a pre-agreed smart contract that the client can deploy, and solving a lot of problems, also saving time and money for both parties. So where does Streamr come into play in this scenario? As I mentioned earlier, Streamr allows entities or developers to manage a large volume real-time data streams off-chain because of the limitation of throughput on most of the public blockchains. And at the same time, Streamr offers modules that allows data streams to interact directly with the smart contract functions via what we call event triggers. That way, you can deploy complex applications that leverage both real-time data and the blockchain capabilities. So the cold chain monitoring regarding the refrigerated good transportation is just one of the many use cases which can be applied in other industries. For example, someone could create a real-time data stream of a flight arrival and departure schedule and create a smart contract that will automate partial refund in case a flight is delayed. Using so or doing so will transform a bad user experience into good ones for airlines and can create a lot of goodwill and probably save a lot of inefficiency in the middle. Before going into further details, I wanted to show that we do have a repository we have created, Streamr-IATA Hackathon. We have created this documentation for the IATA Hackathon, which is a hackathon focusing on airline industry. Here you can find all the cold chain monitoring explanation, all the tools that we'll be using in this webinar, and then also how you can replicate. To mimic the temperature from the truck, we're using a Ruby tag, which is a self-contained temperature sensor. You have a link to the main website in case you're interested in learn more. This is the tag we're using, and it's already active. And also we'll be using a Raspberry Pi 3B as gateway to push the sensor data from Ruby tag into Streamr. We are leveraging our JavaScript library run on Node.js on the Raspberry Pi. And here, if you want, you can have the link to the specific repository to install it and run yourself. So now let's dive into the first part of a smart contract deployment. We are using Remix for this demo. It's actually pretty handy, Solidity IDE, in case you want to give a try. And in the you can find pretty good tutorials on how to use it too. So this is the cold chain monitor smart contract smart contract that we have created. Our senior Ethereum developer user actually created this contract. And in this repository, Streamr dev code chain demo, you can actually find the code for this contract. You will have a simple version under code chain monitor and also a complex one. What we're using today will be the simple version. That will have the main subset functionality needed to mimic the whole transport. We're probably not going to walk through the whole logic or line by line of this smart contract, but I wanted to highlight a few important parts. And so when you deploy this smart contract, you have to provide a few parameters to the constructor, and I want to just explain a few points about those. So the canvas parameter provider is the third-party entity, or like the neutral application entity that will be running the whole logic, keeping track of the penalty, if any, and also triggering the final payout distribution. The customer is going to be the client that pays for the shipping and cost. The service provider is the shipping company that will be actually transporting the good. And we are using a ERC20 token as a payment method for this scenario. The reason why we are using a payment method for the ERC20 token as a payment method is because we want to leverage some of the features that the ERC standard has, and the primary one is the allowance. What the allowance feature gives users is that at account A could approve the spender. So let's pretend account B to spend up to a certain amount on its behalf. This means, for example, account A could give account B 100 token as a spending limit allowance. This will allow account B to spend up to 100 tokens without having to ask permission each time to account A. Account B could decide to spend in one transaction all the 100 tokens, or it could spend 100, like trigger 100 transactions with one token each. This can come very handy on a lot of complex applications, or if you're trying to build an escrow system. So the escrow can get funds from an account, deposit itself, and then pay the parties once the certain events are being met. So this is the smart contract that we are deploying, and a quick look on the Ethereum Rinkeby. You can find both smart contract. This is the code chain monitoring smart contract, and then this is the ERC20 token. The token is called the TLLC, standing for Transport Core LC that we're creating. Inside the Ethereum Rinkeby, you can actually see what, of course, you can see the whole contract, the name of the smart contract, and you can read all the variables that we mentioned before, the parameters, and you can actually write to the specific functions too if you want. Now, now that we have deployed both smart contracts that we needed, both the code chain monitoring and also the token, let's tackle the second part, which is how can you handle large volume of data, real-time data streams, and how you can interact with deploy the smart contract on Ethereum blockchain with that data stream. Now, before going specifically into the Streamr platform, let me give you a quick overview of Streamr and the tech stack that compose the whole Streamr ecosystem. So we have the data marketplace, which allows buyers of data and also like providers of data to create streams on the data marketplace, and for buyers to buy them via subscription. And we have the Streamr network, which handles all the data streams and also the pub/sub logic behind it. Of course, we have the smart contract and Ethereum integration capability. we are using the Web3.js to interact with blockchain, Ethereum blockchain directly, and what we call event triggers, where you can create certain logic on Streamr canvas, and once there's logic met, then the trigger will be sent. We have the visual editor that we'll be using very soon to create all our logic in canvases. Is a drag and drop system that you can build complex logic without much code needed. And also the Streamr engine is an enterprise grade data engine that allows you to manipulate or aggregate data in real time very quickly and efficiently. Now, I have created 3 canvases for this demo: Streamr cold chain monitoring, shipping company canvas, and customer canvas. I think the best way to showcase this whole demo is to give you an overview of the final product first, and then we can work backward by showing how you can actually build this product. So this is the main logic behind the cold chain monitoring demo. Let me give you some breakdown of the components. So this is the stream where the data is coming into via the Ruby tag through the Raspberry Pi. And you can see like the data is coming in real time. And the temperature right now is 21.9 degrees Celsius. If I put the sensor on a heat source, you will see the temperature increase in real time. You can see 22. Now we reach 23 and so on. And this data stream is linked to what we call an overage accumulator. And as you can see, the overage accumulator, you have a threshold, which is the temperature set by the client. And if you go above a certain threshold, the logic on the accumulator will start accumulating those overage. And as you can see from the graph or from this table, the overage sum is already accumulating. So this will be kind of accumulated for the penalty system, and it will run for the whole journey of the transportation. And then once a certain trigger, in this case, we have what is called get event module, which listens to event of the specific smart contract. And once the shipment arrive trigger is pushed directly by the client that receives the good, the overage accumulator will actually send the output, which is, it's accumulated sum, into the Ethereum call module, which triggers a call function to the payout function with this parameter as the input. And the payout function will take in the overage sum as a penalty calculation, and that will distribute the payment accordingly. So if there were no penalty, the shipping company will receive 100% of the pay, and if there was some penalty, then some of the token paid into the escrow account will be actually sent back to the client who paid it initially. Now, just to show you example of the flow, so we have a separate canvas for the shipping company and one for the customer. The reason why we created those separate canvases is because we wanted to mimic the example of those entities accessing the trigger via their own system, which is separate from the logic of the cold chain monitoring, which has to be neutral and independent of those two entities. So now, just to show you the whole flow, let me stop. This canvas was running real time. Let me sign in again. So let me refresh. So okay, now this is stop. Let me start the canvas. So as you can see, the temperatures are coming in real time. but nothing's happening to the chart or table for one reason. Even if the, as you can see, even if the temperature is above the threshold, nothing's being triggered because we actually have event trigger control here. And what this control states is that only after the order accepted has been triggered, then we are starting this overage accumulator. This means that even if the shipping company hasn't accepted the order yet, meaning the good has not been received by the shipping company and the journey hasn't started yet, we don't want to start accumulating penalty because it's not their fault or it's not like applicable yet. So let me give you an example. Let's warm the sensor above 26 again. Okay, as you can see, nothing happened. Now, let me trigger the accept order. So what this trigger does is actually sends a call to the deploy contract on the order accepted. So this is similar to as if you trigger this contract, like this function, and the contract directly on Ethereum. So let me push it. And one thing to note with most of the blockchain and the Ethereum is that transactions are not instantaneous. They have a delay of a few seconds to 15 because blocks needs to be mined first. As you can see, as soon as we trigger the order accept, you can see sensors being accumulated here because above 26. Now, if we wait a little bit for the sensor to cool down, the overage sum logic should stop accumulating because it's below the threshold, of course. And another important factor is that, as you can see, the output is printed on very frequently. If we connected the output of the overage accumulator directly to the Ethereum core, that would trigger actually immediately the payout function, which is not what we want. We want that function to be triggered only after the refrigerated good has been accepted, like by the end client, which the recipient of goods. As you can see, the temperature is below 26. Now the overage sum is stable, it's not accumulating anymore. So this is mimicking the flow or use case of the track might actually go through like some variation of temperature, like certain period might be above, certain period below, it might go above again. As we're going above, you can see the 27 degrees is starting accumulating again. Now, let's assume that the shipment has traveled across the US and has been received by the client. So the customer, the Ethereum account with the customer, confirms that the shipment has arrived. I put a button, like a manual trigger here, but even here you could create actually another automated trigger. For example, you could send a HTTP request post to this trigger or embed in other web applications, of course. This transaction has been mined successfully. Now the trigger will send into the payout, overage accumulator will send its own final output into the input. And as you can see, you got mined right now, and then this means the payout has been distributed, but because there was some penalty, you will see from the Ether scan that the shipping company hasn't received the full payment, but a fraction of it, probably a small one because we didn't spend too much time accumulating, but some portion of it will be sent back to the client. So you can see 99.09 was sent to the shipping company, and 0.91 was sent back to the client as a refund due to the penalty. For the brief period that the temperature was above, probably the food didn't get spoiled so quickly, but would be a incentive because there's a penalty system for the shipping company to actually maintain the temperature below the threshold for as long as possible, or for the whole journey, supposedly. Now that we have seen this whole logic flow, let's see let's break down each component. So first of all, let's look at the stream and what that actually means. So for this specific use case, you can have take a look at the stream section. The stream that we're using is called the Ruby streamer, and this is where we're pushing the Ruby text sensor data. As you can see, it's coming in real time. If you click it, the data is being sent in JSON format, has multiple fields, and the one that we're interested in is the temperature. But you could do also a combination of humidity and temperature by creating a new transport monitoring application, of course. And now that we have this stream, let's see how we can rebuild the whole application that I just showed. Now, you can double click on the canvas. So the canvas is where you actually build the logic with the modules. We have many modules available: time series, text, Boolean, custom modules, etc. So now we want a stream. So you can use the search function here with the Ruby streamer. You can see this is the stream. Just to have a double check that this stream is actually sending data, you can call a table module. The table module simply displays the raw output of this stream. So we can switch to real time. Okay, as it's supposed to, this stream is sending data in real time. Now we can stop the canvas. Another function you have here is you can double click to the name of the canvas and rename it. It's called chain test. And you can save it. Now that we know we're getting data through this stream, now let's start building our logic. The overage accumulator that you saw here is actually another canvas that we have built that we are using in a different canvas. So this is an additional feature that Streamr offers, which is if the whole structure becomes, or the whole canvas starts becoming too complex, you can actually build different canvas and utilize each canvas into each other. So in order to get another canvas you have pre-built, you just search for the canvas module, and then you select the one that you're interested about. And as you can see, there's a bunch of input here and also output defined. Now, just to give a clarification of what this canvas actually is about, I can show you actually the specific canvas. So overage accumulator true. So this module is what we call a Java module. What the Java module allows you is actually to build custom modules via Java. The reason behind it is because for some use cases, the requirement is so specific that it will be very difficult to have a module ready-made available for that. For example, in our case, the code chain monitoring requirements were very specific, so we needed to build a custom one for our needs. And if you go into the code, you can see where we are defining all the inputs that we're going to it, and then just a simple logic that says if the input, which is a value of the temperature, is greater than the threshold, because we are getting the difference. If the difference is greater than 0, then start summing a penalty point system, and then we just send the sum out. So this is a pretty simple one, but nothing stops you from actually building a much more complex. So once you have the module ready, you can actually connect the two. You can connect the temperature to the value input. As you saw, our visual editor, which is this entire platform, is actually pretty user-friendly drag and drop system, so there's not much coding needed. But of course, if you want to build something complex, you can always do it with Java module or some other system. So now that we have connected the overage accumulator, let's add also a table to the output. And then let's add also a chart, as we had in the previous section. Now, I think we can actually run this one in real time to see what happens. So the temperature is 23 degrees. Sorry, actually I forgot to connect a few other things. So as you can see, we're missing the start value. So let me add a constant to trigger the start. Will be 1. And if we really want, we can add a reset, of course, where 0 is false if we switch to 1. And then the threshold we can put to 26 as before. Now we can start. Now, as you can see, because the temperature is below 26, the overage sum is 0. Well, let's try to warm up the sensor. It's going above 26. Okay, as you can see, it's starting to accumulate as supposed to. And it will stop accumulating if it goes below 26 again. Now, we have this basic flow as we need it. However, as I mentioned earlier, to make it a little more realistic, what we want is also like a trigger to start this whole overage accumulator logic only after the package has been received by the shipping company, because the package might be en route before getting to the hands of the shipping company, or the sensor might actually not even recording the right temperature yet. So let's stop this canvas and add that logic to it. So to achieve that, we have to do a few things. One is we need to get the smart contract. First, the event of a smart contract. So we have a get events module. But in order to get the specific events of a smart contract, we need to define which smart contract we are looking at. So if you have seen this one, you can see we have what is called a get contract at, and we specify a specific address. So now we're going to do the same here. So what this module does is it allows us to specify which contract we want to work on, and it pulls the API code directly. Sometimes it pulls automatically, sometimes it doesn't. So in case it doesn't pull automatically, you can go to Remix where you have deployed the smart contract. And in this case, the code chain. And you can go back to the compile and copy the API code from here directly. If you click on the details, you can see actually the name, metadata, the bytecode and ABI code and more. So because we have the ABI, now we can connect the contract to the get events. And you can see the events gets recognized immediately. So what we want to do is create a logic that says let this overage accumulator start. So this is start trigger only after the order accepted event has been triggered. Now we have a module just for that called sample if. So what this sample if module does is that it waits for input trigger of any value, in this case the order accept one, and only once it receives that, only after it has received that trigger, then we'll open the gate to a specific stream. In this case, the stream that makes the overage accumulator start. Now, if we have done everything correctly, we can save and start. So it's 23. Let me warm up. So according to this new logic, even if the temperature goes above 26, it should not trigger the accumulator, which means this should not change at all. Okay, as you can see, nothing changed, even if it's above 26 now. Now, let's send this trigger. I mean, like, let's send the trigger that says shipping, the shipping company has accepted the order. Now, this function call has been triggered. Let's wait for the blockchain to mine this transaction. Okay, the transaction has been mined, and we can go back here. As you can see, it's starting accumulating again. It started from 0 because we just restarted this canvas, but now because the temperatures are actually above 26, it started accumulating because the trigger has been detected, the event. Now we have a half of the whole logic build, meaning we have the stream data coming into the overage accumulator. We have the trigger to start accumulating. We have the temperature threshold that we can set. Now we have to build the last one, which is how do we trigger the payout. Now we have a module called Ethereum call to trigger functions, Ethereum smart contract functions that actually requires input. So it's not just an event that you listen to it, but you actually trigger the function with input. Now, as you can see, it's asking for overage sum. We are looking at the payout function. Now, we could potentially connect this overage sum output directly to this input for the function, but this function will be triggered immediately as soon as this overage accumulators create some output. But that's not what we want. What we want is actually wait for the whole journey of the transport to finish and then trigger it, because we don't want to trigger multiple times, and we don't want to trigger the wrong time. So then we do the same logic. We get a sample if module. This is the trigger, and in this case, I want the shipment arrive trigger to dictate when I want to send the overage sum value to the function. And now we can actually build a table to see the final transaction happening. Let's see. Let's get the error, the gas used, block number, and transaction hash. We can save it. And also to make things a little more interesting, because as we saw before with these cameras, the deduction was pretty insignificant, meaning like was only less than 1 token being deducted. So now let's try to change the overage accumulator calculation. As you can see, we had here divided by 1,000. We can just remove instead divided by 10. Apply, close, and save. Now we can refresh. And save. Now let's record this page just to make sure everything's saved. Okay, perfect. Let's give a try now. So the temperature is 26. Perfect. But as you can see, even though it is 26, nothing's being accumulated because, of course, we're waiting for the first trigger, which is the shipping company to accept the order. Now we just send the trigger. So whenever you build application, always keep in mind of the time lag for the application to be mined. As you can see, now there's the trigger. The function started accumulating again. See the numbers increasing. Those numbers are much larger now because we have lowered the fraction from 1,000 to 10, of course. Now let's pretend the shipping has been received by the final customer. So we send a trigger here. The transaction has been mined. This means here we should see a new transaction of the payout being mined soon. And voila. Everything is in these cameras. As you can see, you don't need to do anything. All the triggers are handled by the shipping company and the customer, of course. Now, let's go to check this transaction on the Etherscan. Okay, let's wait a second. As you can see, once we increase the magnitude of the penalty, now out of 1,000 payment, 800 is gone to the shipping company, and 127 token is being sent to the customer or client that pay for the shipping. Now, this magnitude can be, of course, arranged depending on the severity. If a company was transporting pharmaceuticals, this could be actually much higher compared to a company transporting, for example, some refrigerated goods. Now, just to give you a quick example of what is the difference when you trigger the functions directly via Streamr modules compared to, of course, to the direct ways or like other alternative ways of triggering function. One of the ways you can trigger, of course, is via your command line on your computer if you're running your Ethereum client. Another way is actually going to the Etherscan and the specific smart contract that you have deployed. Here's the transport C, and you can connect to MetaMask, which is this Chrome plugin where you can manage your all your Ethereum accounts. So here, for example, you can approve the allowance that I just mentioned. You can approve another spender to spend a certain amount of token. You can transfer tokens in the mint. In this case, we have the code chain monitoring contract. You can read all the parameters that has been assigned during the deployment, or write contract, meaning calling the specific functions here. You can call shipment has arrived, order accepted, or payout by sending also overage sum penalty number. So just to give you a final example, let me stop here. Let's see if this camera is stopped. Okay, let me restart. But instead of triggering from the canvas, we can trigger from the, actually, let me get, let's reset the values. So as you can see, it's above 26, but nothing happened because waiting for the trigger of order accepted. So I'm going to use a control. Make sure you are on Rinkeby testnet network. Then let me do an accept order. So here you have to actually manually confirm it. And then once it's confirmed, it has to be sent to the block and be mined. Once it gets mined, we should see the, as you can see, it got triggered by 0 because I put a reset here, value is 1. Now let me change the value. Now it's not reset anymore. And it should start accumulating. Now, as accumulating over the journey, we can go back to this scan, and we can trigger the shipment has arrived with a different count, of course. Let's pretend this account is the shipment arrived. Okay, shipment arrived actually has to match whoever is the service provider. So this address 07A. Let's see who's reject. Zero 7A. Okay. Good. Let's see the code. Actually, yeah, nice the reason. Shipment arrives can be triggered only by the customer. So the customer, let's see, is a 0x5f. Okay, the account 1. So you can actually add those security check that, for example, the service provider or the shipment shipping company cannot trigger shipment arrive, but only the customer actually from the account can. Now let me trigger. We can actually see the transaction is pending. This means it has not been mined yet, and our canvas is of course still accumulating. So we wait for transaction confirmed, and of course, let's see. This is the transaction that has been sent in the payout. Now let's see the transaction. You can see 214, 785. So 214 went to the client, and 785 went to the shipping company. Let's see how much was the one earlier that we triggered. The earlier was A72, so this time we actually penalize more because we let it run longer, of course, mimicking a longer journey, of course, for the transport. Now that will be it overall. So the reason why you want to create a separate logic so that each entity will control their own side, and they could not trigger the other side, of course. So things can be fair.